Alrighty, we are doing a mini lesson on simplifying radicals with negative radicands. So what this means is we are going to be reducing radicals with a negative number inside. Now I do have a little reminder that when we take the square root of a -1, that negative is what is giving us I for the imaginary value. So let's look at example 1. We are taking the square root of -36. Well, the first thing we have to get rid of is this negative. And as I just mentioned in our reminder, the negative will come out to give us I, leaving us the square root of 36. Once you get rid of the negative, now we can actually reduce the square root of 36. The square root of 36 is a perfect square, which if you use your calculator, you will see it will give us the value of 6. Now this I, to be proper, will always go behind our number. So our answer here is 6I. All right, let's look at example 2. So same process. We're taking the square root of -200. So the first thing we have to take care of is this negative. So I'm going to take that out to give me I, leaving us with the square root of 200. Now that our radicand number is positive, we can start to simplify. Square root 200 is not perfect. Now to break this down, I use a factor tree. What this means is I am looking for two numbers that multiply to 200. The only thing is we cannot choose 1 and 200. It has to be other numbers. So I'm going to go ahead and use 2 and 100. Now our goal with a factor tree is to get all of the ends of the trees to be prime numbers. A prime number means you only have 1 and itself to multiply. For example, 2 is a prime number. Only 1 times 2 equals 2. 100, though, is not prime, meaning I can break this down. Again, you can break it down in many ways. I'm going to just go ahead and do 10 and 10. But again, you could have chosen 4 and 25, 2 and 50. Again, there's many options there. Now, what I recommend is once you break down a number, like we did for 100, is to cross out the number you broke down. This will just make it easy to not reuse a number we don't want to use. Now let's break down the number 10. Two numbers that multiply to 10 is going to be 2 and 5. Because I broke down the number 10, I'm going to cross it out. Now, as I've already mentioned, 2 is prime, so that's good. 5 is also prime, so we are done with that side of the tree. We can now focus on that second 10, and I'll break it down the same way. 5 and 2. Again, we broke down the number 10, so I'm going to cross it out. 5 is prime, so that's good. 2 is prime, so that's good. Now, as you will see, the only numbers that are left, not crossed out, are prime. That is your goal. Once you have only prime numbers left, we are going to group these numbers together. With square roots, we are going to group them in pairs, so two of the same. So we have 2 2s. Those are the same. I'm going to group them together. And we have 5 and 5. I'm going to group those together. And then we also have the I that will also be grouped with this stuff. So now, how do we take this into our actual answer? I'm going to take each group and it gives you one of those numbers. So my 2 2s will give me A2. My 5 5 will give me A5. And then we're going to multiply those together. Now we don't want to forget about our I, so I'm also going to bring that down to multiply. So 2 times 5 is 10. 10 times I is 10I. This is going to be our outside value from the square root. What's going to go on the inside is any leftover values. So right now we're looking for things that we did not cross out, so those are gone. We also circled those, we can't use that. So the only thing that's left over is this 2. So I'm going to take this 2 as my leftover, and that's going to go inside the radical. This is my reduced or simplified radical. All right, well, thank you so much for watching.